Good afternoon, everyone. I am Astha Lutare, and today we will discuss end semester examination question number 1. So, our question is we have given a non-linear equation fx is equals to x square minus x minus 1 is equals to 0, and we have to find its roots by any numerical method, and we have to perform the following task on it. So our first task is to describe the algorithmic steps or present a flow chart for the method clearly indicating initial conditions or assumptions, iterative formula or rule, and stopping criteria, numerical results, and choose an appropriate initial guess or interval. So first let us discuss what is bisection method. Bisection method is a bracketing method for finding roots of continuous functions. It repeatedly bisects an interval and selects the subinterval where the function changes sign. So, step 1 is to choose an interval AB such that f of A and f of B have opposite signs. Let A is equals to 1 and B is equals to 2, and we put these values in f of x, then the value of f of 1 is minus 1 and f of 2 is 1. Since f of 1 is less than 0 and f of 2 is greater than 0, there is a root in the interval. So in step 2, we will calculate the midpoint. C is equals to A plus B upon 2. Here the value of A is 1 and value of B is 2. So 1 plus 2 upon 2 gives us answer 1.5. Then we will evaluate this value in f of C, that is 1.5 square minus 1.5 minus 1. And then we will got the answer minus 0.25. Since f of C is greater than 0, the root lies in the interval CB, that is 1.5 and 2. Step 3, we will calculate the midpoint between 1.5 and 2. Therefore, C is equals to 1.5 plus 2 upon 2. It will give us the answer 1.75. Now we will evaluate f of C, that is f of 1.75. Then we will got the answer 0.31. Since f of 1.5 is less than 0, the root lies in the interval AC, that is 1.5 to 1.75. Step 4 is to calculate the midpoint between 1.5 and 1.75. So the midpoint will be 1.5 plus 1.75 upon 2. So the answer will be 1.625. Then we will evaluate 1.625 in f of x. We will get the answer 0.015625. Since f of 1.5 is less than 0, the root lies in the interval AC, that is 1.5 and 1.625. Then we will repeat the steps, that is calculate the midpoint between 1.5 and 1.625. The midpoint will be 1.5625. Then we will evaluate f of 1.5625. We will got the answer 0.12109375. Since f of C is less than 0, the root lies in the interval 1.5625 to 1.625. And we will again calculate the midpoint because the root lies in the interval. Then the midpoint will be 1.59375, and if we evaluate this midpoint in f of x, then we will get the answer minus 0.053710935. Since f of C is less than 0, the root lies in the interval 1.59375 to 1.625. This will continue, and we will got the answer as 1.59375. Now we will discuss the algorithmic steps for bisection method. So first step is to start, then input function fx, interval AB such that f of A into f of B is less than 0. Then we have to check condition, is f of A into f of B is less than 0. If not, display error, that is invalid interval. Choose different A and B, then end, and if yes, then continue. Step 3 is to compute the midpoint. we will compute the midpoint by a plus b upon 2, then give the midpoint, that is f of m. Fourth is to check convergence. If f of m is less than tolerance, then root found m n. If not, update the interval. If f of a into f of m is less than 0, set b is equals to m, else set a is equals to m. Our last step is to repeat. Go back to step 3. Then there is a flow chart that is same as the algorithm. First we will give the input. If f of a into f of b is less than 0, then compute midpoint. If no, invalid interval, choose different a and b, and so on. Here we have given the flow chart for iterative calculation, step by step in tabular form, such as current approximation, function value and error at each intersection. Here the iterations are 1, 2 up to 14. Midpoints are given as we have calculated earlier, that is 1.5, 1.25, 1.375, 1.4375 and so on up to 1.4142445. We have put the midpoint in function fx, then the values are given below and the errors. This is the geometrical interpretation illustrating how the method approaches the root. Here we have given m1, m2, m3, m4. These are the midpoints, and fx is equals to x square minus x minus 1. It is the function. And the last part is to estimate the error at each step and demonstrate the convergence behavior and order of convergence of method. First is error estimation in bisection method. In bisection method, the error at each step can be estimated as the length of the current interval divided by 2. That is bn minus an upon 2. En is the absolute error at nth iteration. An and bn are the lower and upper bounds of the interval after n iterations. The maximum error after n iteration is less than or equal to b0 minus a0 upon 2n, where a0, b0 is the initial interval. Second is convergence behavior. The bisection method guarantees convergence if the function fx is continuous on ab and fa into fb is less than 0. The error decreases exponentially, meaning the method converges linearly. Third is order of convergence. The order of convergence p and asymptotic error constant c can be defined as limit n to infinite mod xn plus 1 minus x upon xn minus xp is equals to c. For the bisection method, order of convergence p is equals to 1, error constant c is equals to 1 by 2. Thank you.